Another kind of inheritance is X-linked inheritance. X-linked inheritance is about genes that are carried on the X chromosome. Now, in humans, we have individuals who have 2 X chromosomes who are female, and individuals who have an X and a Y chromosome who are male. For X-linked genes, females will carry 2 copies, like all other forms of inheritance. There's 2 alleles in females, but males, since they only have 1 X chromosome, will only get 1 copy of any X-linked allele. We're going to use hemophilia as our example here. So hemophilia is a genetic disease where an individual cannot produce certain proteins for their blood to clot, right? It can be a very serious disease for those who have it. The normal allele for blood clotting is X big H. So note I've written my X and I've used a superscriptive H there. This is the normal blood clotting allele. Individuals with hemophilia then, hemophilia is recessive, so we're going to have that represented as X little h. So these individuals carry an allele for hemophilia. Okay? And so as you can imagine, we can have individuals who have the genotype X big H, X big H. They would be females without hemophilia. We can see individuals with X big H, X little h. They would be females also without hemophilia, but with the potential to pass it on. And then we might see individuals who are X little h, X little h. Those would be females who have hemophilia. And then for males, there's only 2 possibilities. They can either be X big HY or X little hy. If they have the big H, they'll have normal blood clotting. If they have the little h, they'll have hemophilia. So let's look at an example where we have a man who is normal. He does not have hemophilia, so his genotype would be X big HY. And he has offspring with a woman who is also normal, but is a carrier for hemophilia. So her genotype is X big H, X little h. Okay? So we're going to look at whether or not there's a possibility for their offspring to have hemophilia. So we'll set up our Punnett square as we have before. Okay, and so we've got 4 offspring, all of whom have different genotypes. So we have some individuals who are X big H, X big H. Those would be normal females. We have other individuals who are X big H, X little h. They're also normal. They're not going to have hemophilia. Again, they might be able to pass it on to their offspring, but they don't have the disease. Then we have X big HY. That's a normal male. And then we have X little hy, and that is a male with hemophilia. Okay, so out of 4 possible offspring, only 1 has hemophilia. But it's not only that. Out of 4 possible offspring, the daughters will never have hemophilia, only the sons might get it. So with these X-linked recessive traits, there are situations where daughters will never have the disease, but about 50% of the sons will. So you can use this information to solve the question you have about hemophilia.